Okay, today we are in section 8.9, graphs of linear equalities, page 436. All right, so in example 1, we are checking the solutions of a linear inequality. Basically, it means this, okay? An ordered pair is a solution to an inequality if when I plug it in, it makes the inequality true. It's not a solution if it's the opposite. If when I plug it in, it makes the inequality not true or false. All right, so let's test our solution. Before we do that, the first number in our ordered pair, is that our x or our y value? It's our x value. Okay, so that's still the same. So I'm just going to plug in those numbers into my inequality. So I've got 2 times 0 minus 3 times 1 is less than 6. Well, what's 2 times 0?
0.
What's 0 minus 3?
-3.
Okay. Could you do that part in your head? Okay. So I'm okay with you cutting out this middle step right here. All right. I'm okay with you not showing that. But here's what I have to see. I have to see your substitution. And I have to see that you say -3 is less than 6. And yes, that is true. Okay, so that would be my boxed answer. I'm answering the question. It is a solution. Isn't it true that -3 is less than 6?
Yes.
All right, so since that's true, it would be yes. All right, I want you to go ahead and test the second ordered pair for -2. All right, so we're plugging them in. 2 times 4 minus 3 times -2 is less than 6. So what's 2 times 4? 8. What's -3 times -2? +6. Okay, so again, you don't necessarily have to show this step. I would say it is helpful, okay, because you can really see it. And now, what is 8 plus 6? 14. All right, and is it true that 14 is less than 6? No, so I say no, and I draw a line through my inequality, just like we drew lines through our equal sign when we're testing solutions. All right, now let me make this clear too. Let's say that you forgot that this was a +6. Did anybody do that? And they said -6. So if you have the wrong number here in your answer, you are not going to get credit for having the right answer. Does that make sense? Okay, because yeah, you're right. Okay, 2. Well, actually, if you said 2 was less than 6, you would have said yes. But even if you answered this part correctly, okay, even if you say no, if this part isn't right, then you actually don't have the right answer. Does that make sense? All right, so you actually do have to do the math correctly. 14 is less than 6, and then you would say no. All right, any questions on testing solutions? Pretty straightforward. Now, here's the good news on graphing an inequality. I graph an inequality as far as where my points go, the exact same way that I would graph an equation. I start with my y-intercept, and then I use my slope to determine my next point. But here's a couple things I want to point out on this slide. Okay? One thing is, you notice that what kind of a line do you have here? You have a dotted line, right? So it's a dotted line when your inequality is either less than or greater than. It's a solid line when you have the equal to component. We'll talk more about that in a second. And then you see this big area that they shaded in? That's an important part of graphing an inequality, and we use what we call test points. So that's just a quick overview to what we're about to do. All right, now, you do not have to write every single word of this. I'm capturing it on the recording, so if you want to go back and watch the video, it'll be on there as well. But here's some important points about graphing inequalities. You graph the inequality, what does that say? Exactly like you graph an equation. So how do you do that? You plot the y-intercept first, and then use the slope to plot your second point. Familiar? Sound familiar? It should, because that's how we do linear equations too. Now it says use a what kind of line? Dash line for just a less than or an equal or a greater than. Use a what kind of line? Solid line for if it has the equal to component. All right, so that's important. The second part to that, so once you have your line graphed, the second part to it is to test a point. And here's the thing, you can choose any point on that coordinate plane to test. Now, I suggest that you use what point?
0, 0.
So you at least need to write that in your notes. Use the point 0, 0 as your test point. When can you not use it though? There's a time when you can't. Unless it is directly on the line. Okay, then you have to choose a different ordered pair. But that rarely happens. So 0, 0 is really easy because isn't it pretty easy to multiply any number times 0? Because what's it going to be? 0. If you pick another number and you have to multiply it by a fraction, you might get the wrong answer. But you multiply a fraction by 0 and what do you get? 0. Okay, so it's just a little bit easier to test your to test the point. So if a test point is a solution to the inequality, you shade the part of the graph that includes your test point. And that'll make more sense in a second. If it's not a solution, then you shade the other part. All right? Okay, so enough talking. Let's actually see what this looks like. All right, it says graph y is greater than or equal to 2x plus 4. I do not need you to do this one on your graph paper, but I do want you to identify your y-intercept and your slope. Go ahead and identify those 2 points. All right, so pretty easy, but y-intercept is going to be what? 4. And then my slope is what? 2 over 1 or just 2. Okay, so here's how that looks. Okay, here's how that looks now on a graph. Now, it kind of goes off the graph, but you see where does the line cross the y-axis? At what point? At a value of 4. Okay, so you graph these lines the same way that you would graph an equation. Notice that what kind of a line do I have? Dotted or solid? Why is it solid? Because it's got that equal to. Okay, so they did a solid line. And now we have to figure out which side of the line is going to be shaded, so we use our test point. All right, so we've got 0 is greater than or equal to 2 times 0 plus 4. We're testing our solution now. Is it true that 0 is greater than or equal to 4? No, it is not. So that's why they shaded the part of the graph that did not include 0, 0. Does that make sense? So if it's not a solution, if your test point is not a solution, you shade the other part of the line. If it is a solution, then you would shade the part that included your test point. You think you can try one? I know you can do it. Okay? All right. Okay, I want you to try this one right here. X plus 2y is greater than 6. This first one, just the first one. Now, what do you notice right off the bat, though, about this inequality? It's not in slope-intercept form, so the first thing I need to do is write it in slope-intercept form, and then I can graph it. So you're going to go ahead and graph this on your first graph on your papers. All right, so we start off by rewriting it. All right, so we just do a little bit of work here to kind of rearrange the inequality. Did you get that? Yes. Okay, so if you mess that up, you're really in trouble for your graph, okay? So don't make a mistake there. Now, what is our y-intercept? Okay, so we come over here to our graph. And, sorry, let me get this. Okay, and yes, our y-intercept is 3, and then what was our slope? Negative 1/2, so I go down 1 over 2, and solid or dotted? Dotted, because it's not equal to. Okay, now I have to figure out is which side of the line do I shade in? So what do I do? What do I do to figure it out? I need to use my test point, okay? So I come back over here, and this is This is my test point right here. This is what I did to check my solution. My test point, I used 0, 0. So I plugged in 0 for y and 0 for x. Okay, well that's easy. What's negative 1/2 times 0? 0. So is it true that 0 is greater than 3? No, it is not true. So I come back and I highlight the region that does not include my 0, 0 test point because it wasn't true. If it was true, then I would have highlighted the other side. Okay, did y'all get this? Yep. Raise your hand. All right, good job.
Yeah, I totally know.
Any questions? Any questions?
No, I see.
Okay, now in example 3, now I have inequalities that only have one variable. X is less than 3, okay? And y is greater than or equal to negative 2. You don't have to do these on your graphs, I just want you to pay attention. All right, so in this case, it's going to either be a horizontal or a vertical line. In the first graph, where do you think you're going to plot your point? On the first one. X on an x value of what? 3. And that's what you're going to see here. On an x value of 3, you have your line. Why did they do a dotted line?
Because it's not equal to.
Because it doesn't have the equal to, it's just less than. Okay? So, and then it's a vertical line. Now all I have to do is test my solution. Is it true that 0 is less than 3? Yes, it is. So that's why they shaded in the region or the part of the graph that included 0, 0. Does that make sense? All right, so what about y is greater than or equal to negative 2? Where do you think we're going to plot the point there? On a y value of negative 2. Exactly. Now let's test 0, 0. Is it true that 0 is greater than negative 2? Yes, so that's why they shaded in the region that included 0, 0. All right, simple enough. Why is it a solid line? Because it's equal to. You think you can do 2? All right, I want you to try these last two on the checkpoint. X is greater than or equal to 1, and y is less than 3 on your last two graphs that you have set up for your notes today. All right, so x is greater than or equal to 1. So where do I plot my point on x? I plot it on 1, and I draw my straight line through. And I'm going to do my best. I mean, all I have to do is trace it, right? Oh, goodness. I messed up. Hey, quit laughing at me. All right, whatever. Guess what? You don't have to be perfect either. Aren't you relieved? Okay, so now, wait, hold on. Is it supposed to be a solid line?
Yes. Because it's equal to.
Okay, it is supposed to be solid. I thought it was supposed to be dotted for a second. Okay, so now, how do you figure out which side to shade? Plug in 0. Is it true that 0 is greater than or equal to 1? No. So guess what? You shade the other side. All right, so you shade the side that does not include your 0, this side, the right side. All right, then for y, for your third one, we had y is less than 3. So where's our point plotted? On a y value of 3. Solid or dotted? Dotted, because it's just less than. All right. This is not easy to do on the iPad. Anyway, you get the point. All right, arrows on both ends. And then we do our test point. Is it true that 0 is less than 3? Yes. Yes, it is true. Okay, and I do want to see this work for your test point, okay? I want to see this work on your regular paper for your test point. And since it is true, then I shade the region that included my test point. The bottom part. All right, who got those two right? Awesome, good job. One more example, example 4. You know we always have to do word problems. This is actually exactly like your number 11 on your homework tonight. So you're welcome. Okay, this will help you on that problem. All right, it says you have 100 pounds of clay to use for making bowls and vases. So guess what? One of those is going to be your x and one of them is going to be your y. You have to determine which is your x and which is your y value. Okay? And I would just go in order. Whichever one comes first, make it your X value. Whichever one comes second, make it your Y value. You need 5 pounds of clay for each bowl and 2 pounds for each vase. So now we need to write an inequality. Well, on one side of the inequality, we're going to have our total. What's our total? What's our total pounds? It's 100. Okay, can we have more than 100? No, it's got to be either less than or equal to 100 pounds, right? If I plan out 105 pounds, guess what's going to happen? I'm going to run out of clay, right? I only have 100 pounds of clay. So that's how you figure out if your inequality needs to be less than or greater than. So everything over here in my combination of bowls and vases has to be less than or equal to 100. If I use 100 pounds, do I have enough? Yeah, that's okay. All right, so now, how many pounds of clay do I have? 5, so that's going to be 5x. What's going to be my other term? 2 what? 2y. 5x plus 2y is less than or equal to 100. So now, am I ready to graph it? I wish. Now I've got to write it in function form. I don't have a whole lot of space to work here, but it's going to be 2y is less than or equal to negative 5x plus 100. Then what do I have to do? Divide everything by 2. All right, and then it's going to be y is less than or equal to negative 5 over 2x plus 50. Guess what? We're not graphing that. Because what would you have to do? Man, you'd have to really what you would have to do is you'd have to do a scatter plot. And you can see that actually in your book. They just draw the graph differently. Basically, we're not skipping every other line from 2 to 50, are we? Okay, so we would actually just do different increments. But regardless, okay, this is the most important part to me. All right, that's the most important part, is that you can actually write an inequality from a word problem. All right, and then 3 possible combinations. Once you shade in, so let's jump back over here real quick to one of our other solutions. Whichever part you shade in, trying to get over here. This is where I want to be. Okay, any one of these ordered pairs in here can be a possible solution. So if they want a combination, like number 11 on your homework tonight is going to want a combination, just pick 3 ordered pairs and make sure you match it up with the value you've given that variable. Does that make sense? So if you picked an ordered pair of, let's say, 4, 5, you would say 3 possible combinations. You would say the ordered pair you picked that was a part of the solution. Why did it do that? Hold on. All right, there we go. Was, let's say, 3, 4. So what did we determine was my x value? My bowls, right? So it would be 3 bowls, 4 vases. Does that make sense? It might not exactly match up, but that's basically what you're doing. You're going to pick 3 ordered pairs out of your solution, and you're just going to put a label to it. All right, based on the values that you gave x and y. All right, hopefully that made sense. If you understand that, that's everything you need to know for the last section of Chapter 8, Section 8.9.